Alright, so we got video 2.3, and this is going to be talking about how to solve absolute value equations. We've talked about how to graph and transform and stuff. Now we're going to be looking at algebraic equations. So, just like any other time I ask you to solve throughout the year, so all year in all your algebra classes, pre-cal, everything, when we say solve, we're asking you to get the variable by itself. So I see that my variable in these two is x. My goal is to figure out what x values make this equation true. When we're solving absolute values, so my first example, we need to get the absolute value piece by itself. What I mean by the absolute value portion is the piece of the equation that I'm considering absolute value are the bars, so that the absolute value of x plus 2. I need to get that by itself, very similar to what we would do with parentheses that we've seen in the past. However, and this is very, very important, so hopefully it captions this right or you're listening with sound, we do not distribute inside an absolute value. We are not going to take that 3 and put it inside and make that 3x plus 6. So it's similar to parentheses, but we are not treating it exactly the same. So I'm going to get absolute value of x plus 2 by itself. I want that to be the only thing on the left side of my equation. So just following order of operations, which hopefully we know by now. If we don't, we can talk about it in tutorials. Come see me in the morning. But the first thing I need to do is move this 6 to the other side. So now I'm left with 3 times the absolute value of x plus 2 equals 12. And again, I want the absolute value piece completely by itself. Which means, I need to divide by 3. And it leaves me with the absolute value of x plus 2 equals 4. Okay? Now, here is where it gets a little bit special with absolute value. Hopefully you remember our discussion about how absolute value is just a representation of distance. So if I go 4 units to the left or 4 units to the right, 4 and negative 4, with absolute value, they're the same quantity. So when we're solving absolute value, we're trying to figure out where is the absolute value of x plus 2 equal to 4. When we're doing that, since absolute value is distance, positive and negative numbers, when we take the absolute value of them, they will both end up positive. Due to that, as soon as we get the absolute value piece by itself, we're going to break up into 2 equations. We will not drop the absolute value bars until this step, but there's a reason for it. So we're trying to figure out some number plus 2 will gives us. Then we take the absolute value of that number, and it gives us a distance of 4. So when we do that, we're going to say that some number plus 2 equals 4. But also, because the absolute value of positive 4 and negative 4 is both positive 4. So we also know that x plus 2, it could be equal to positive 4, or it could also be equal to negative 4. Notice, I did not change the x plus 2. The piece inside the absolute value bar is protected by the absolute value, so we will never change what's inside the absolute value bars. I did nothing with x plus 2. I just wrote it down twice. However, I did change the 4. For one equation, I have positive 4, and for the other equation, I have negative 4. and then you just solve an equation like normal. So I get x equals 2, and I also get I have no idea where negative 6 came from. Sorry. We have negative 6, negative 10. Holy Toledo. There we go. Negative 6. When you stop, you can just check it. So 2 plus 2 is 4. And then negative 6 plus 2 is negative 4. But as soon as we take the absolute value of negative 4, we end up with the positive 4 we were looking for. So if x equals 2 or if x equals negative 6, either way, we get the answer we're looking for. So both of these answers are true. Same thing here. I'm not going to explain near as much, but I need the absolute value piece by itself. So we need to get the absolute value piece by itself. So I need to move the 1. Once the absolute value piece is by itself, we break up into 2 equations. The first equation, we just copy down exactly what we're dealing with. And the second equation, we flip the sign of the answer. However, here, I want to point out something. We're going to go right here, and I want to show you absolute value is a representation of distance. So, if absolute value is a representation of distance, we will never state distance as negative. I use the example in class, like if we were giving people directions, we would never tell someone, oh yeah, you turn left at the red light and go negative 6 miles. We use left and right as a direction, but the distance we state is always positive. So I think we'll like this. It's something we need to know and remember, but if absolute value is a representation of distance, and absolute value can never be negative, if we get to a spot like this, where the absolute value is equal to a negative, we don't have to do the work we did on the last one because it has no solution. And I'm about to show you graphing real quick, but if you don't believe me on this example that doesn't have a solution, graph the left side, graph the right side, and see if they intersect. And if you trust me, they will not intersect. Okie doke. So when you're solving algebraically, get the absolute value piece by itself. Once the absolute value piece is by itself, we want to break up into 2 equations and solve for both answers. All right. So last thing we're going to do, and I'll be quick, we just solved this one, or something very similar to it, I guess, on the last one. But here we can solve algebraically or we can solve graphically. I'm going to ask you to do both. The directions will be very clear. So which one I'm asking you to do. Hopefully by now we enjoy graphing because it's pretty straightforward. In the video, I'm going to graph like I don't have access to a calculator. Obviously in class, I'm not going to steal your calculator away from you when I ask you to graph. So as long as we know how to use our TI-84, we're good. But I know from our past discussions in class that the vertex of the absolute value is -2, -3. It's H and K, and all year I will be calling H a liar which I explained in class. But since it says x plus 2, I know the vertex is at negative 2. So, to solve this graphically, I guess I should probably say that at the beginning. You've solved by graphically a ton, but I'm going to graph the left side of the equation, which is the absolute value of x plus 2 minus 3. Then I'm going to graph the right side of the equation, and I'm going to see where they intersect, because I want to know where does the absolute value of x plus 2 minus 3 equal 1. And if I want to know where this quantity equals this quantity, I'm going to see where they run into each other, or where they intersect. So I know the vertex is at negative 2, negative 3, so I'm going to plot that. Negative 2, negative 3. And the slope of my absolute value is right there. Since I don't see it, I'm not pointing to the bullet point, I'm pointing to in front of the absolute value. Since nothing's there, we know that that's an understood 1. Therefore, if my slope is 1, I know I'm going to go up 1 and over 1 in both directions. And remember, absolute value is a v. So make sure you go in both directions. It's not just a line. Then I'm going to graph the right side of my equation, which is just the number 1. So where is this graph equal to the number 1 at every x value? Well, just the line 1. So I graph the v, or I graph my absolute value, using the vertex and the slope. That gets me the blue piece of my graph. The red piece of my graph comes from, I want to know where the absolute value is equal to the number 1. So I go to the y value of 1, draw a line. Now, I'm looking for the points of intersection. So they intersect at an x value of 1, 2, 3, 4, negative 6 and 2, which, since you can see my giant watermark, this is a trial. I cannot go back and show you the last problem we solved on the last slide. But if you remember, when we had this absolute value, we got negative 6 and 2 also. So whether we graph it or algebraically solve it, we're good either way. But I will be specific on which one I want you to do on certain problems.